again. Today's shout out goes to Carly. She was the first person to send me a picture of herself making a funny face. So again, those shout outs are hidden. You have to really look for them if you want to get a shout out. So make sure you're participating in all the course activities. Everything we're using is either this YouTube channel or it's located in Dora. Actually, probably mostly Canvas. I'm not going to use the science website so much. Probably I'm not going to use the Connected, the Wonders, just because I feel like what we're going to read is so much better than that anyway. So that being said, welcome back, and we're going to jump into today's lesson. All right. I know you guys are probably wondering, Mrs. Cat, where's your glasses? Well, when I film, there's a lot of glare on them, so I don't wear them because I sit in front of a window. So I'll go ahead and pop those on my face right now. All right, here we go. All the things that we learned before are coming together, adding and subtracting mixed numbers with unlike denominators. So we have added and subtracted mixed numbers where the denominators were the same. And remember, we had some of those tricky situations where you had to change it after, or you had problems where you had to borrow. So that is all coming together, and it's all going to be incorporated in these problems we're going to do today. So the first one. The book actually even sets them up stacked like this, which is how I prefer to do any sort of adding and subtracting where you have to create a common denominator. So if you prefer sideways, you could write it sideways, or this is what I do. As always, I would recommend a separate piece of paper just because I need more space for my thinking, and I assume most other people do as well. So here we go. I've got this first problem here where I have 3 and 5/6, take away 2 and 1/3. I need to have a common denominator. So I can use my math facts and know what I know about 3s and 6s. I can use my multiplication chart and go down my 3s and 6s and look for this first number that they both have in their list, which is the number 6. I could multiply 3 and 6 and get 18, which is in both of their lists. You'll notice 12 is also in both of their lists, but the best number to use is the smallest number they have in common. Also, because this guy already is 6, so I don't have to change him. He already is in the 6th form. I just have to turn a 3 into a 6. Super easy. I like to rewrite my fractions so that they're on top of each other. So I'm going to go ahead and rewrite this one. And then I'm going to ask myself, how do I turn a 3 into a 6? 3 times what would give me 6? So 3 times 2 gives me 6. So the rule is if you do it to the bottom, you do it to the top. 1 times 2 is 2. So this is now the fraction that I'm subtracting. So 5/6 take away 2/6. 5 take away 2 gives me 3. And then the common denominator stays common. We did all that work to fix it. We're not going to change it. And then 3 minus 2 gives me 1. I could also rewrite this. There is a number that will go into 3 and 6 to make it smaller. If I divide top and bottom by 3, I actually get 1 and a half. This is equal to this. The reason why is because I did the same number top and bottom, just like we learned in previous lessons. All right, in the next problem, I could go and list all my multiples of 6 and list all my multiples of 5. I could use my multiplication chart, go down them until I find a number that they have in common, or I could multiply 6 and 5. 6 and 5 happens to be the number they have in common. 6 times 5 is 30, and 5 times 6 is 30. So I need to use a fraction of 30. So I go back and ask myself, 6 times what gives me 30? So if it's 6 times 5, then on top it has to be 6 times 5. 1 times 5 gives me 5. So my new fraction instead of 1/6 is 5/30. My second fraction, 5 times what gives me 30? Well, 5 times 6. So the rule is if you do it to the bottom, you have to do it to the top. 1 times 6 gives me 6. Now I can add these together because they're both over 30. 5 plus 6 gives me 11. Same denominator. We did all that work to make it, so we're going to keep it. And 3 plus 2 is 5. This can't be made any smaller. So there's my answer. All right, the next one. In this problem, I could list all my multiples. I can go down my list of, 6 and 9. So I could go down my 6s and down my 9s to find what they have in common. I can multiply 6 times 9 and end up with 54. there's multiple ways that you can do this. Remember, you try to use the smallest number because it means less work later. So when I look at these two numbers, I'm going to list some multiples for this one. 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6. Okay, now I'm going to list my multiples of 6. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. So you can see there's actually a couple things that they have in common. They both have 18. They both have 36. If I kept going, 54 would also be on here that they would have in common. But again, like we had previously said, using the smallest thing they have in common is usually the best because it means I don't have to do as much simplifying in the end. So I'm going to make two new fractions. Ugh, sorry, didn't leave myself enough space. I'm going to write them over here. Two new fractions where 18 is the bottom number. 6 times what is 18? Okay. 9 times what is 18? So 9 times 1, 9 times 2. 9 times 2 is 18. And so I have to multiply top by 5, or by 2 because I multiplied the bottom. 5 times 2 gives me 10. In the second fraction, 6 times what is 18? Well, 6 times 1, 2, 3. So I'm going to do the same to the top. 1 times 3 gives me 3. So now that they're both 18, I can subtract this problem. 10 take away 3 gives me 7/18. And then 5 take away 3 gives me 2. There's my answer. All right. Now this next one is a little bit tricky because I have to borrow. I also show you another method for how you can solve these problems as well. Remember when I said you can unmix first and then make the changes? I'll show you both. I don't usually prefer unmixing because sometimes you end up with really big numbers that you have created. It's not necessarily the most efficient. Borrowing works just as well. And I personally think is a lot easier than having to unmix, make common denominators, and then remix to get your answer. I really think that just borrowing is a lot easier. So let me back up and tell you, let's get to the common denominator. So I've got my 10 and my 5. Well, 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5. I know that'll work, right? And then I'll do my 5s. 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6. So you can see we have multiple numbers that they have in common. The smallest number on both lists is the number 10. I like that because this is already set up as 10, so I don't have to make any changes here. So my new fraction over 10, this already is 10, so I'm just going to keep it as a numerator of 1. Again, 5 times what gives me 10? Well, 5 times 2. So if you do it to the bottom, you have to do it to the top. Now I have a problem. I have 1/10 and I have to give away 8/10, which I can't do. I can't just say 8 minus 1 is 7. That's not how this works. So what I'm going to do is I'm going to borrow. I'm going to make him 1 smaller. So he's a 7. 7 plus 1 makes 8. I'm going to take this 1 and add it to my fraction, but I'm going to add it to my fraction as a fraction. What number over 10 would be equal to 1? Well, we know any number over itself is 1. So I'm going to add to this 10/10. Okay, 10/10 is 1. 1 plus 7 is 8. So I just changed how the problem looked. I didn't change how much money I have. So for example, if you have $5, like you have one $5 bill, and you broke it up into 4 $1 bills, you don't have less money. You just changed what it looked like, right? Or if you had $2 and you changed one of those dollars into quarters, so you had 1 paper dollar and 4 quarters, together they're equal to $2. You didn't change how much money you had, you just changed what it looked like, okay? So here I changed my 8 and 1/10 into 7 and 10 tenths. That's 8 and 1/10. So together, this is 11 tenths. Okay. 11 tenths take away 8. Now I can do that because 11 is bigger and I can take away a smaller number. So 11 minus 8 is 3 tenths. I'm going back over here. I borrowed. I don't have 8. I have 7. 7 take away 3 gives me 4. All right. This is my preferred method of how to solve a problem without having to unmix. I know that when I was growing up, every time we had a mixed number, we were told that we were supposed to unmix to solve. But it's not the most efficient way to unmix everything and then do the work. I'll show you what I mean by that. This is the unmix first rule, okay? And really works great for subtraction and adding too, because then you have all the correct numbers when you unmix it. But it's not my preferred method. So I'll show you back the exact same first problem that we'd worked on. This problem here. So, sorry, let me adjust my view. So here I have 3 and 5/6. Take away 2 and 1/3. So the first step in the unmix first procedure is to unmix. 6 times 3 gives me 18, plus 5 gives me 23/6. All right, here 3 times 2 gives me 6, plus 1 is 7/3. Then from here, I make a common denominator. Just like we did before, 6 was our common denominator, so I'm going to make this over 6. And then this doesn't have to change because it already is 6, right? 6 times 1 is 6. So here it stays the same. This guy becomes times 2. So it becomes 14/6. All right. So now we go ahead and subtract. So that gives me 9/6. 23 take away 14 is 9. This is gone because it's been mixed into these problems, right? So this whole fraction is no longer. So then I ask myself how many 6s are in 9. Well, there's 1. There's 3 out of 6 left over. Another way to write that is 1.5. So I get the same answer here that I got here. But as you can see, I unmixed first to get it. So I didn't have this. I didn't do the same thing here. I still got the same common denominator. Okay. Now, I don't necessarily prefer this because, for example, if it wasn't 6 that I was using, I have to multiply with 23 to find the new common denominator, which I don't really like having to do. I don't like to have to do extra steps like that when it's just as easy. So I'll go ahead and show you that one where we had to borrow, where you unmix first, okay? So here, this problem, we had 8 and 1/10, and we had 3 and 4/5. So first, I'm going to unmix. 10 times 8 is 80, plus 1 is 81/10. Here, 4 times 3 is 15, plus 4 gives me 19/5. Now I have to make them a common denominator. Before we chose 10, a common denominator of 10 and 5 would still be 10. So this guy already is in tenths, so I don't have to change him. Remember, all of these whole numbers are gone. This guy isn't, though. I have to multiply him by 2. Now, I don't know about you, but 19 times 2 is not what I think of as being fun, right? So 2 times 9 gives me 8, carry a 1. 2 times 1 is 2, plus 1 is 3, so that makes 38/10. Okay, do you see why just borrowing that whole number over is a little bit easier than having to multiply, numbers like 81 and 19 to make common denominators? It's not really the most efficient. Just borrowing from your whole number is way more quick and easy than having to unmix first. But this is how I learned growing up. We unmixed everything before we added and subtracted them, which again, I don't prefer. Okay, so here I'm going to take 81, take away 38. So 81 minus 38, borrow. 8, 9, 10, 11. Oh, sorry, I'm over here. And here we get 43/10. How many 10s are in 43? There are 4 of them. 10 times 4 is 40, so I have 3 left over. Or if we were showing the math like we had done before, you put the top number inside, the bottom outside. How many 10s are in 4? None. So I'm going to look at how many 10s are in 43. 4. 40, subtract 3 out of 10 left over. Okay, so as you can see, this is why this work here is why I prefer just to borrow from the whole number and add that 1 as a fraction to make my fraction bigger instead of unmixing first. Okay, again, you know Mrs. Kat's rule. I don't care how you do it as long as you get the right answer. All right. So today's work is in your math book. I'll also email it to parents like I always do. It is going to be page 21, problems 1 through 15. All right. I'll go ahead and make a quiz on Canvas for you to share your answers if you want feedback. Don't forget to check after I've graded it to see how you did. I can also send answer keys to parents so that they have it as well. So I will see you guys next time. Look for the new how to get the next shout out in Canvas. It's going to be on there. All right, guys. Talk to you later. Bye.